Okay, we're back. Hi everyone, and welcome to this week's Learning Space. Hello. I'm one of your hosts, Nicole Gallucci at Southern Illinois University, Edwardsville, with the little red E above my head there. We are bringing you Learning Space, our weekly look at science and education. So this is from the STEM Center at SIUE and CosmoQuest. My co-host through the wall here is Georgia.
Hello.
Hi, Georgia.
I don't have a ready. Aw.
I'm sorry. Well, you should have one.
I
Maybe it was a new thing that they did.
Yes.
Where they made little 3D
print
printed.
up another one, right?
What's that?
3D print up another one.
Yeah, they printed them for people who had submitted their first grant. Even though my grant didn't get accepted, I got an E just for trying. So hooray for that. And we are joined by an awesome group today from the University of Houston. This is the University of Houston Ultralight Mission Group. So why don't you guys, we have Rachel and Michelle and Christopher, why don't you guys introduce yourselves?
Yeah, so my name is Rachel Gamblin. I'm a mechanical engineering senior at the University of Houston, and beside me I've got...
My name is Michelle Nowling. I am a sophomore physics major here at University of Houston.
And Chris?
Yes, I'm a senior physics major at University of Houston, also mathematics. Nice to be here.
Hello, welcome. I had gotten a notification from your professor, Edgar Bering, so one of our friends from the NASA EPO community, about a mission that you guys did, and for some reason I got it in my head you guys went to Antarctica. It's Alaska, so ignore my Antarctica comments. But yes, which is probably a lot colder than most of us have here. I want to say hi to our audience real quick. We have Nancy and Hugo and Guido and Andrew all up in the Q&A app and some more people chatting on the event page. If you're watching this and you want to join in with comments and questions, you can use the Q&A app. There's a little button somewhere on this video saying join the conversation, use the Q&A app. You can use that through YouTube or Google+. And apparently Andrew has put up a tutorial on how to do it on an Android tablet, I think, so that those of you with devices that it didn't work with before, check the comment section of the event page on Google+, because he's got some tips for you guys on how to get a Q&A app working in lots more places. So hooray for that. Thank you for joining us for this special later time. We want to hear a little bit about you guys, the work you do, and what you do, what you did in your last research trip to Alaska. So you guys are doing instruments on research weather balloons. So Rachel, maybe you want to get started with an overview of what you guys do?
So, hopefully I'm unmuted. We started this very long journey about 2 years ago, and it's basically, NASA has this program called the Undergraduate Student Instrumentation Program. And if you're an undergraduate student listening, or if you know an undergraduate student who might be interested in this, make sure that we connect afterwards and I can give you some more information, because basically you get your bunch of students together, you find a professor who will be your principal investigator, and then you basically submit a proposal to NASA and say, this is what we want to do. We think we can do this, we think it'll provide real science, and this is why. Here's our team, here's what everybody will do, here's our project schedule. So you have to put together a real plan. And then you submit that to NASA, and NASA then says, yes, we'll give you money, or no, try again later. And so we did that a long time ago, about 2 years, and that was right before the government shut down and all that scary stuff about NASA and everything. So we'd been accepted, but we didn't know if we'd get our money. And then they came back, and we did, and it was awesome, and everybody did a happy dance. At that point, we were 18 undergraduate students from all different majors. So I'm in engineering, we have physics majors, we have electrical engineering majors, we have atmospheric science majors, we had a psychology major. And that was really the goal, is to have this interdisciplinary team of students who can bring in a bunch of different knowledge sources and a lot of different expertise and learning abilities. So from there, we kind of started in with the implementation of the project. So the idea is that you design, test, build, rebuild. You build it first, then you test it, then you rebuild it, then you test it again. And our final goal, as we set out in our proposal, was to take these things that we wanted to put on weather balloons. You can do it on rockets. You can do it on the vomit comet, what they call the parabolic comet that goes up and comes back down. We chose weather balloons because we wanted to take these kind of existing technologies and update them, miniaturize them, make them lighter weight, lower cost, and so that we could put them on this also lighter weight, lower cost science kind of avenue with these low volume comparatively to other weather balloons. So what we used were latex balloons, and they're 300 gram balloons, and you fill them up with helium. And we took ours to Alaska to study the Aurora Borealis. And after 2 years of designing, building, testing, retesting, rebuilding, we went up there with our team, which had gone down to 11 students, just through attrition and students who had graduated or found things that they just were more interested in besides our project, which, they didn't go to Alaska, and we did. We had a very successful 3-week campaign in Alaska. So we spent the first week, which was frustratingly windy. And so if you have too much wind in the upper atmosphere with your launching balloon payloads, you can't launch them. So when you say that you're going to have a show time, you have a show window with weather balloons. And so that's why we went for that whole 3-week period, and we had people on the ground, students on the ground, who were there to do balloon launches, to do on-site fixing of these different instruments. And I haven't talked much about the instruments because there are so many. We had 7 completely different science topics with 7 completely different instruments, and they all have their own subsystems and all kinds of stuff. I can speak specifically to the VLF receiver.
Yeah, I'd like to hear from each of you which one you worked on.
Right. Yeah, and we'll definitely go through that. So, I mean, I did VLF. Michelle did a star tracker. Chris did a DC electric field measurer. So I'll go ahead and jump into that. For mine was the very low frequency receiver. So my basic design is that we had an air core loop antenna. So you take a really long wire and you wrap it around a frame a bunch of times, and the more loops you have, the better your antenna is, the more sensitive it is. And when you've got a coil of wire, electromagnetics, when you have a changing magnetic field through those coils of wire, you're going to generate a current in that wire. And attached to the antenna, I had a circuit that is designed to measure that voltage that gets induced into the magnetic coil. And then that coil, since I had designed it specifically to have filters and to be sensitive to very low frequencies, then got recorded directly onto basically an MP3 player. So the antenna was maybe about 13 by 13 inches. We used a pool billiard ball rack, actually, and that's how we wrapped the wire around it. Yeah. And then we attached that to a circuit board, probably about maybe half the size of a sheet of paper. And from there, we connected it to an MP3 player, which is no bigger than an MP3 recorder, which is no bigger than an iPod, really. And so once you take these very low electromagnetic waves and turn them into voltages, and then put those voltages into a microphone head jack, you get a sound recording. So what I was doing was taking the Aurora Borealis and the other electromagnetic activity that we could hear and turning it into a sound bite. Cool. A very long sound bite when you're doing a 3-hour flight on balloons. But So that was what I did, and that's what I'm going to continue to be doing probably in the summer. So I did 2 launches in Alaska, and I'm going to do one more in Sweden, hopefully.
Okay.
Oh my goodness.
So that was the VLF tracker. If you guys got any more questions about that, we can answer those at the end. But I'm going to go ahead and let Michelle talk about her star tracker.
Sure.
All right, so my objective was to build a star tracker. I came into the team kind of late, so I arrived maybe the end of November, early December, and so I had a lot to try to get done, picking up where star tracker was left off. So I kind of went a different route. I wanted to do something super simple because we were leaving to Alaska in 3 months. So what I did was I took a regular DSLR camera, and I messed with the configurations. I tested it out to see, what ISO would be great, how long of an exposure I would need. So basically, a star tracker, you want to measure the position of the stars. It helps, if you're putting it on a satellite, to orientate the satellite in whichever direction you want it to be pointing. So basically, I took this camera and I connected it to an external battery source so it would last for the duration of the flight, about 3 hours. And I attached an IR remote sensor to keep triggering the camera throughout the flight. And I also had a magnetometer, which gives me all the data, in which directions it's pointing relative to the camera, the altitude, all that kind of stuff. So I made it really simple. I did 2 flights from Alaska. I also had gyroscopes on the payload to keep it stable enough to where I would get some pictures. It still did spin, but not as fast as it would have without the gyroscopes. Another thing that I want to look at for our next flight is getting bigger gyroscopes to maybe actually stabilize it completely so it won't spin at all. That's going to be really difficult, so I'm looking into it. I do have one more flight here in Houston, Texas. I am granted that for whenever I want to do it, so I think the next time I do it, though, I'm going to mess with the configurations a little bit more. This way, if there is spinning, I can do shorter exposure time, so there'll be shorter star trails, so I can actually identify which stars they are, and just set a higher ISO so I can get a really bright source. So,
Cool.
if there's any questions, I'll be happy to answer this.
Christopher?
I'm going to hand it over to Chris.
Yeah.
Wrong button there. Yes, I was in charge of the DC electric field detector. Essentially what I was doing was I was recreating the double Langmuir probe experiment. What a Langmuir probe is essentially a sphere connected via some rod or some sort to my central processing unit. I also use a circuit board like Rachel. Typically, the Langmuir probe is metal or something, but I prefer to use styrofoam balls because the goal of our experiment was to make it nice and light. So styrofoam is light and it works in cold, and what we did was we covered it with colloidal carbon suspension, and we plugged it in using carbon fiber tubes. The original design had polyvinyl chloride, PVC pipes. Those are also proved to be too heavy, so we used carbon fiber tubes. Those were separated about a distance 6 feet apart each, collected to a preamplification, a preamplifier chip. Without going into specifics, that was used to amplify the signal, generate it through the board, and output it to our central processing unit. And that was to collect a measure of the electric field in the atmosphere. The way I was actually measuring was the potential difference between 2 different points in the atmosphere at the time. And what the board was actually doing was doing the E-field amplification of the signal, and the goal was to see if it could do some of the E-field conversion for me as well. My experiment didn't yield any significant results during short duration flights, so I'll also be having a long duration flight in Sweden. I'll be with Rachel on that. And yeah, that's my experiment in a quick nutshell.
So how high up do these research buildings get?
They reach 30 kilometers. 30 kilometers. That height, the temperature is about 70 Celsius. So negative 70
Negative
Celsius.
70, yeah.
Yeah.
I think you guys said that the duration of the flight is about 3 hours, or does that range just depending on if it's sort of an earlier flight and you're practicing or trying to see what's going on versus a final flight, or does that depend on what the project is that's going up as to how long it needs to be up there?
Technical difficulties.
Okay.
Yeah, so the length of the flight is about 3 hours, but that, like you said, it depends on a lot of different things. It depends on how much you inflate the balloon, and it depends on the ratio of how much you inflated the balloon compared to the exact weight of your payload. So all of our payloads were designed to be less than 6 pounds. So, but if you have a 3-pound payload versus a 6-pound payload, then you would put filling that same balloon with the same amount of helium would take the 3-pound payload much higher, much faster, and so it would pop sooner and then come back down. At the same time, if you underinflate a balloon, so if you take a balloon that is 6 pounds and you only put in enough helium for a 3-pound payload, then it will never reach its maximum altitude and have very little incentive to pop. Because the main reason that it pops is that you have two popping mechanisms. One of them is you just get to a certain pressure, and after you get to that pressure, if you keep rising, the pressure outside is so much less than the pressure inside the balloon that it stretches the balloon out enough that it pops, just like overinfilling a balloon on the ground, like a regular helium balloon on the ground. The other is that you have teeny tiny defects in the balloon all over that just come from manufacturing processes and handling. And once you get up to those high altitudes where it's exposed very directly to UV light and basically just radiation, it'll heat up those spots in micro places, and that'll eventually create all these stresses in the balloon that just, it only takes one, right? It only takes one pinpoint to burst the entire balloon. And so if you don't get it high enough, you can float for a really long time, which is a bad thing if you are trying to get your payload back, especially if you launched in Alaska and it goes over the mountain range.
So about how far away did your payloads end up traveling? I assume you were able to successfully retrieve them.
We were able to successfully retrieve, I believe, 2. So we did, I think, about 13 launches, and we retrieved 11 of them.
Oh, okay.
And some of those were reflights of different payloads. But, yeah, so the furthest one we had go was the first one that we did, and that was, I think, I want to say it was 400 miles.
Oh my god.
And that was a real chunk. That was very bad. If we'd had more than one of those, we probably wouldn't have had the budget for the helicopter time to retrieve the rest of our payloads. Oh, so wow. It was fine to have one like that, and it was a nice trip to go out.
Oh no, froze.
Uh-oh.
Okay, so we have a brief freeze from their end. I don't know if they can hear us. But we also have a question for Christopher from Hugo. Does the diameter, okay, what are the diameter of those polystyrene balls you used, and does the size of those balls affect the resolution, like how big or small of an effect you see?
Yes, size does affect the resolution of the measurement. The diameter of the polystyrene balls I used. I don't actually know off the top of my head.
Give us a
good guesstimate is about, I think they're a good foot in diameter.
Okay.
Yeah, I have it written down somewhere, but I have made the measurements. But yes, the size does affect the resolution of the measurements. The bigger the ball, the better the measurement you're going to get.
Cool.
Actually, our goal was to keep it under 6 pounds.
Right.
We didn't make them. Yeah.
Is that 6 pounds per flight?
6 pounds, yes, per flight.
For the whole thing. Cool. So I wanted to point out, so in the Showcase app right now, if you're watching this and using the Q&A app, you can switch over to the Showcase app using the little thing that looks like a tiny Rubik's Cube at the top of the corner. And I've got a link to their blog page, so it's usip-uh.blogspot.com. In fact, I linked right to the Meet Us or About Us page. And I'll make sure to post this link in the show notes after the show as well, so you guys can check that out. And actually, I'm curious, what was I gonna? Oh, first of all, I'm super jealous because I've never been to Alaska, and I've never actually seen the Aurora Borealis. I've never been north enough or clear skies enough during a major event. So what was it like for you guys seeing the Northern Lights? Was this a first for you? Was this something completely new?
Oh, definitely a first. I've never been that far north, and I've never seen snow. So.
Oh,
Okay.
you were totally overwhelmed then. Wow.
So you were overwhelmed from above and below. How have you never seen snow?
It doesn't happen down here
Okay.
often, if at all.
I forget. My brother lives there, but I forget. Cool. Oh my gosh. So I'm curious what it was like, this whole process leading up to it. You've got a 3-week trip planned. I did a project in grad school where we had a similar thing where we had a few weeks at a remote location. We had to get everything done. How did you prepare everything ahead of time in order to make sure that this trip, you would get the most out of this trip? I see you've all clustered around.
I just saw that too.
The machine. It works.
Yeah.
Difficulty, so I have Rachel and Michelle here.
Okay, so do you want to tell us a little bit about that preparation, how you make sure everything goes?
It was scary. We had 2 separate lectures from our professor, and I think I know why you got the Antarctica one, because he did this similar research in Antarctica.
That must be where I got that, yeah.
40 years ago. And so we had 2 different survival tools, because it's a very real possibility that we're out in the middle of a launch and something happens, we car crash or any number of things, and we have to know how to survive in this environment that's basically trying to suck the life out of you because it's so cold. And so we had to send out for people to maybe donate clothes because none of us had heavy-duty winter gear. We ended up going with rentals from Feathered Friends and from Whitaker Mountaineering, both very great outfits. I highly recommend them. And we had down parkas, we had snow pants. Everybody needed to have waterproof snow boots, heavy-duty gloves, waterproof. A lot of it, we learned sweat and water and wetness, those are the killers.
Mm-hmm.
So as soon as you're wet, then that refreezes on your body, and that causes kind of a cycle feedback problem. So there were times when you'd go out in your parka because you're cold, but as you start working, you have to take your parka off. You have to start delayering.
Oh, wow.
Because if you sweat, then that sweat's going to get to your clothes, and your clothes are going to stop being cold, even when you sit back down. So it was a lot of culture shock for our students.
It was the worst in the hands. Definitely the hands where he suffered. You wear gloves. You wear so many different kinds of gloves. You wear glove liners and like basically the smaller gloves, the big heavy duty gloves. You gotta take them all off when you're working with the very small parts on your payload and fixing it out when you're in the field. And it gets really cold. Your hand starts freezing up, and eventually you have to return to like going back and forth between the warmth and cold because if your fingers get too cold, frostbite, and they fall off. Well, they have to get it, but.
We definitely had a tag team kind of deal where we had people going out in the cold and then say, all right, I'm out. I need somebody to take over the task for me.
Yeah.
So we were very lucky to have such alerts to us.
And how did you prepare ahead of time to make sure you got the most like science and data out of your project? Did you have contingency plans in place? Did you have backups? Did you practice, anything that you would have had to do out in the field back at home?
Yeah, we did have test flights in Houston, so that
Okay.
gets everybody familiar with the whole process of balloon launching in general. And once we got to Alaska, we had that week kind of a preparation also, and we did flight dry runs, basically. So we had people all in their gear. We were indoors because we wanted to practice it inside first, and then once we're at the launch site, we do it outside and that kind of stuff. And so we kind of had everybody it was what we call a dry run, and we did everything except inflate the balloon. And it was a really important process for us to all go through so that when you're at the launch site and you make the 30-minute call to the airport saying, hey, we're going to launch in 30 minutes, you kind of got the clock's ticking on you and you need to get it right the first time. Our first time out, actually, we learned a lot because we popped a balloon. We went out to launch at our first location, and everything seemed great. Surface winds were fine. They were projected to be fine. Then we started inflating the balloon and started kicking up on us. And so we kind of thought, all right, well, let's keep going through with this. Let's get it done. Let's get it done fast. And in the middle of inflating the balloon, we were almost ready, and just a huge gust came and folded it over. Like, it's a vertical balloon, right? And the whole thing just flopped over.
Oh my God.
Onto the truck, and it popped immediately.
Oh.
Got footage of that from 2 different angles. Too.
Yeah. So
She was covered in it.
on my face. So that was
Oh man.
everything you can do, the better, obviously. And we did what we could to try and be ahead of the game in that aspect.
Very cool.
Gosh.
We had a question a little bit earlier for Rachel from Atom Synergy. I've seen the Northern Lights. Lucky you, I still haven't. I've seen the Northern Lights, but I've never considered what Aurora might sound like. So this is the radio waves being converted into sound. Do you have do you post any of this data, the recordings, or Michelle, maybe your images? Have you been sharing any of that?
We haven't yet. There's still a lot of post-processing that has to go through. So we've been focused on that. And we are undergraduate students. So we were out of class for 3 weeks, and now we're coming back, and we have all these tests and labs to make up, and then finals are coming up in 2 weeks.
Yeah, I was going to ask him, like, are you on a trimester system or something? Because that's 3 weeks of your spring semester.
Right. Well, so one of them was spring break.
Okay.
2 weeks of lectures. But
Why not?
there's a lot that we're still catching up on. But I would like to make that data publicly available. I don't currently know of any restriction or non-disclosure agreement that we've agreed to that says that we can't.
Yeah.
There is, I can tell you right now, if you wanted to listen to the Aurora, there's a website called auroralchorus.com. It's exactly what it sounds like, auroral, like an adjective describing Aurora, chorus, like a bunch of people singing.com. And that's a hobbyist who kind of does basically what I was trying to do. And he's got some free CDs of data that he's collected that he has posted online, and I love listening to them. And he's got all these great companion descriptions of them, and he's really descriptive, and you can tell he's really passionate about what he does. So if you're interested in looking at that in the meantime, before I can get my data up, which probably won't be as good as his, just because I had 3 weeks to collect my data, and he's had 3 years.
Yeah, yeah.
But yeah, I would like to get our pictures posted up and any kind of actual source data that we have up on probably on our blog, just because that's the most, the easiest to handle, the most accessible format that we have right now, and it'd probably be hosted on our Google Drive and then get linked to on our blog.
Yeah, I was going to ask about that. So that's a nice way to keep everybody up to date, and either you guys or the public, whoever you're kind of writing to. Do you all three, or does everybody kind of contribute to that blog, or is it a few people kind of taking the lead on that?
A few people kind of taking the lead. I certainly encourage everybody to write on the blog, but not everyone has confidence in their writing abilities. I try to get them to practice, and I want to. Point of this project is to push people outside of their comfort zones, right? And
Yeah, I guess. Definitely.
yeah, get your hands into as many different areas of practice that you haven't been in. So I've written on there. We had one member who unfortunately had to leave us. Abdul has been writing on there, and we've also had Megan Pina. She's worked very much on the blog as well. So, and she also handles our Twitter account. So we try and have a kind of social media blogging process and kind of a presence so that people know what's going on. And really, one of my main goals with that aspect is to make sure that kids know about this project, that undergraduate students know about this project, because I talk to people about what I'm doing for my senior design project, and they go, "Oh my God, that's so cool! How did you get into that? Like, what's the GPA requirement?" And I was like, there wasn't one. You just needed to know about what was going on and to be involved with the right people at the right time. And if you're at a campus who doesn't have a professor who's as involved as Dr. Baring has been, it's definitely an opportunity for you to step up and for the students to go and present and say, "Hey, I really want to do this and I think I can get funded. Let's go for it." So that's been a big goal of our blog and our Google Plus page and our Twitter account and that kind of stuff.
Cool. What's the Twitter handle? I think you guys tweeted at me earlier, but I haven't.
USIP _UH. It's either underscore or dash.
Those dashes.
Those. Awesome.
And I know George is giggling about the blog thing because I've tried to get her to write.
Oh yeah, well, yeah, that was totally. I can totally relate to.
Yeah.
Who are hesitant to blog a little bit, but I don't know.
But I love
I keep
yourself.
trying.
Half of my entire blog posts have been, "Sorry guys, I haven't posted that much."
Yeah. Typical.
Whatever you can write down, I highly recommend everybody do it, any age, no matter what, because it's going to improve your communication skills and it's fun.
Awesome. Cool. So, and I also see you've been talking to, I don't actually see who the author of this blog is, but to elementary school students as well about your experiences. Was that one of you guys?
Oh, yeah, I did do that.
Yeah.
Yeah, through the Society of Women Engineers, we had a group of elementary school kids come out, and their teacher brought them to campus, and I did kind of a PowerPoint presentation talking about how I'm a girl in STEM and how you don't have to be. I tried to stress the fact that I was just a normal person, and I am a normal person. Despite the rumors that you might hear, I am very, very normal. And so I talked about how I like to dance, but I also like math, and so I picked engineering, and now I'm getting to go to Alaska, and they didn't know what the Northern Lights were, but follow up with them sometime as their first grade selves once school starts back up.
Okay, cool, very cool. You guys sent, actually we have a quick question from Hugo Burnham. How do you source your helium? As I understand it, there's helium shortages, and it's kind of under a premium. How do you guys get the helium for these balloons?
CSBF.
Columbia Scientific Balloon Facility.
That's right.
Okay.
NASA gave it to us.
Yeah, they
Short answer.
Part of the grant, yeah. Cool. Now you guys sent us some pictures. Did you want to share some of these pictures and tell us what's going on?
Yeah, let's put them up.
If you want, I can screen share, because Brain, they may be a little out of order of how you sent them to me.
Yeah, they weren't in any particular order.
Oh, okay, good. They came up as unnamed 1, unnamed 2. This one makes me happy because I love dogs.
Yeah, it made us happy too. So we had that week where we were mostly in the planning stage, and so we did have a little bit of time where we got to enjoy ourselves. We may have ended up regretting taking that time to enjoy ourselves later on in the project, just because we felt like we were short on time at the end, but we did get to go dog sledding, and we went to, it was called Just Like Magic, or Just Short of Magic.
Just Short of Magic.
And they do tours, basically. They do dog sledding training classes, and they do tours of their property. So you got, everybody on our team got to ride on the dog sled. It was very, very interesting. Yeah.
So this is probably one of my favorite pictures out of the whole thing, because the story is my hand almost froze getting this picture because I had to take my gloves off. And when we went dog sledding, it was probably one of the colder days we were there. It's negative 30 degrees Fahrenheit.
Oh.
Yikes. But the dogs look happy. Okay, so what do you guys? This looks like you're inflating.
Yes.
Yes.
Yeah. That is the inflation process. So we had a truck that had our helium tanks in the back. We had a hose that we found out it's very important to keep your hose warm.
Okay.
And you want it to be cold at night, because at a certain temperature, that PVC hose, that soft PVC hose, does a ductile brittle transition. And then you don't want to have cracks in your line, because then you're spitting out valuable helium the entire time you're inflating. And so we've got, kneeling on the ground there is Megan Pina. We've got Chris standing there. There's Michelle with her aircraft radio in hand.
That's you.
I think that's me in the back, yeah. Just checking the helium levels, because you have to actually attach the hose and then open the valve on the tank to tell what the pressure inside the tank is.
I'm putting on a second layer of gloves there.
And I have
What's this over here?
That's actually a frozen river that we're sledding on. So the story behind this picture is we were actually hiking to go pick up one of our payloads that we had launched. I think, wasn't it one of our first launches?
Yeah.
So that was the first launch that we were going to hike to get. We had to walk about 1 mile to 2 miles off-road, and it landed just off the side of the river. So we walked, along the frozen river, and we had to go through like this foresty area, and the snow was about waist deep once we got to the forest. So it was a very interesting hike. Definitely something I'll remember forever.
This looks like a fun group picture. No, a very cold group picture.
Yeah, I think that was one of our first launches, maybe. And Dr. Leffer is off to the side there.
Yeah, so starting from the right side of the picture, the side with the date on it, that's one of our professors, Dr. Leffer. Then down with the hat is Michelle. Above her in the blue hoodie type thing is Diego Guala, who actually joined our project from the beginning, then went to study abroad in China.
Oh, wow.
And then came back to help us out on the actual launch in Alaska.
Cool.
And right next to him in the green, we've got Hamza, Ahmad. Down right under him in the blue, we've got Daniel Hermosillo. Kneeling in the center, we have Erica Marrero. And then way far left, that's Megan Pina, at the launch site earlier.
I should point out briefly, Hamza wanted to join, but had some last-minute stuff came up, so he wasn't able to make it. So we're sorry you couldn't make it. And then we've got, is this another launch, I'm taking it?
Yeah.
So he's actually releasing the balloon in this picture.
Okay. Cool. What's on his head?
It's a GoPro, yeah. So we were
it's a GoPro.
We recorded most of the launches, but if it was a nighttime launch, it was hard to see the videos unless we had flashlights in every direction. So we do have footage of pretty much all the launches.
Cool.
How do you decide who does which role? There's some logical way to do that, or do you just kind of whoever feels like I want to release the balloon this time, or what do you guys think about it?
This is the second option. We had 2 people who worked with Dr. Leffer on campus for about a year doing a separate project where they launched balloons rather frequently. So they were kind of more experienced, and they showed us the ropes, and by the time we had people feeling comfortable, we switched through all the different tasks. Because each task has a varying level of hand exposedness.
That's critical.
Traded out the burdens and joys of each different task.
So we have some more comfortable looking indoor pictures as well
Right.
of lab work.
Clipping wires, soldering iron, got all your different components very neatly organized in different parts, and you don't have to
Yes.
count the resistor values every time.
Yes. Very important. And this is like a jumble of wires, but you've got...
Yeah, so that's what I've been working with for gaseous pump experiments that use electrochemical. It's electrochemical cell. So you have two reactants, sensors, and as they ozone or nitrous oxide or whatever you're trying to sense, they generate a teeny tiny current.
Okay.
And the current goes into the microprocessor, which you can see on the laptop, which is trying to code the microprocessor. And you can run that volt proportional to the concentration of the gas, and they excited to see their
Hang on a sec. We're having a little bit of sound issues. Georgia, can you lower your... We're getting echo inside. No, Georgia. Yeah, we're getting a major echo from your computer.
Try it now.
That seems better. Okay, I think that's a bit better. Can you go back over that a little bit? Sorry, there was an echo there.
Yeah, so this was gaseous compounds group, and we actually had about 4 students working on this because it was a very intense project. So you can see she's got a tube in her hand, and we pumped air through that with a small centrifugal pump, and we had electrochemical sensors that you have teeny tiny amounts of the reactants in the sensor, and as you flow this gas, this atmospheric composition through it, the reactants will react with either ozone or nitrous oxide or whatever it is that you're trying to look at in the atmosphere. You've got different reactants for each different thing that you're trying to sense, and as that goes over, it generates a teeny tiny voltage that's proportional to the concentration of the gas that you're looking for in the air. And then that voltage goes to a microprocessor. We use the Arduino format, Arduino Uno revision 3 specifically. And you can see on her laptop in the back of the photo that she's actually programming that microprocessor at the same time that she's working with these pumps and electrochemical sensors and all that kind of stuff. So that was one of our more involved projects that got to launch kind of towards the end of our campaign. And we're excited to see their data come out in post-processing sometime in the next 2 weeks.
Excellent. And then we've got this one here. What is this? What payload is this?
So this is Hamza and Diego's baby. This is the spectroscope. And so that long tube that you're seeing come out of the white box is a carbon fiber tube that has a lens at the end of it. And in that lens, inside the box, there's more assembly, and it's all attached to a camera. And they have a diffraction grating. So they're trying to point this lens at the Aurora Borealis. And the light that comes through the lens goes through the diffraction grating and hits the camera sensor. So they take a picture, basically, of this diffraction of the light so they can try and tell which gases are most represented in these different Aurora events that we're seeing. That particular one is our tragedy. We didn't get to recover it on the second launch that it got to go up. So if you're in Alaska and you see a big orange parachute laying in the snow with a white box and a black lens attached to it, my phone number is on that box.
Oh, really?
So where it is.
And you'll get 2 GoPros, right? We're offering 2 free GoPros for the recovery.
Spread the word.
Wow, okay. That's actually serious business. Excellent. That's cool.
Coordinates, the last coordinates that we have anyway.
Okay. Yeah, somebody, one of our commenters, Douglas Crandell, was tracking a balloon. I don't know how to get to these links, but apparently there's ways to track them as well if you're watching. Okay, so we have a couple more pictures. It's a puppy.
Yeah. I love dogs. I love the dog sledding place.
Mm-hmm.
And it's hard to tell people's identities because of the gloves.
Who's who?
I know everyone. On the right, that's Dr. Bering's wife, Barbara. Next to her on the left that's Megan with her goggles and neck gaiter on. You can't see her much. Next to her is one of the dogs, and Rachel's giving that big old puppy a hug. Above her is Arian Etchishami in the blue. Next to him is Erica Marrero. Right next to her on the left is Michelle over here with her neck gaiter on. Behind her is Hamza with his neck gaiter and his sunglasses. And that brilliant young chap on the right, also known as the Grand Rouge, is me. In a big red parka and red pants. So.
That's impressive. Now we can't call you out on it because we don't know, but your friends can call you out if you totally made that up. But we believe you. And this last one's pretty impressive. So is this a balloon going up as well?
Yeah, another shot of another launch.
Very cool. Very cool. Awesome. So I got to follow along a little bit from tweets, and one in particular has been stuck in my head because there's a parody song of it, but apparently you guys were up all night to get data. What happened?
Okay, so I'm gonna guarantee that you heard about this through Dr. Barry.
Yes, I heard him. He was tweeting me the whole time you guys were there.
So I don't know if anybody has been listening to the radio for the past year, but Daft Punk came out with a new album, and one of the feature songs was "Up All Night to Get Lucky."
Mm-hmm. I have danced to such songs in clubs full of astronomers at conferences. It's bizarre.
So we had it wasn't us, but a group of students did a parody called "Up All Night to Get Data," and since almost all of our launches were at night, and we did a lot of work at night in our lab, it resonated with our group and kind of became the anthem of the trip.
Nice, because he tweeted that at me. I'm like, that would make a great parody. Oh, it's already been done. Right, you're actually referencing the parody. I hadn't seen it yet, so that made me happy. But yeah, you really throw yourself into that experience for 3 full weeks of just constant work and constant doing everything. So you guys have some post-processing to do. What else is next? Are you guys planning to present this at meetings or anything like that?
Absolutely. We actually have a massive student paper competition coming up on Saturday.
Yeah, the AIAA. Everyone's going. We're all presenting. We all had to submit abstracts before we left, and the papers were due while we were on our trip. So, yeah.
That face. Yep. The face of
that's like cool. Good luck with
we're
that.
also going to present the whole project. We did before the group. We went to the AGU fall meeting, the American Geophysical Union, and we presented there. We're going to do the same thing again this fall, and we are probably also going to be going to Dallas in June for the AIAA meeting there. That's bigger than the student conference. And we'll be presenting about what all we found and our next steps for sending some of our CERT experiments to the piggyback flight in Sweden in August.
Awesome. And we have a question from, where'd it go? Hugo says, it looks like you all had a really good time. You had, so you had a couple lost payloads, and you saw snow and Aurora for the first time. Can you say anything else in addition that was the highlight of the experience for you? And I'd like to hear from each one of you guys what your highlight was.
Well, so our very last day before we had to start packing up and shipping out, our professors, after spending 3 whole weeks, driving there and driving to the airport and back, decided that they were going to stay behind and run the telemetry. At the time, we only had 4 students left over. It was me, Rachel, Megan, and
Daniel Canales.
Daniel Canales, that's right. We had 4 students, and we were very short-handed, so we had to send all 4 of us down there to fly these balloons. Now, it doesn't seem to be that big a deal. It's just students flying a balloon, except the fact that we had to fly 4 balloons, and 2 of which had to be flown where there was sunlight to get good data, and then 2 of which had to be flown where there was no sunlight to get data. Now, astronomical twilight happens around 11:30 in Alaska around time of year. It's near the equinox. So we had to go out at about midnight, 1 a.m. to...
Hour and a half drive from Fairbanks into the Great White Wilderness.
Yeah. So we went to the airport and back in the morning.
When we say airport, we don't mean the Fairbanks airport.
Right, right.
Hour and a half out in the middle of the boondocks airport.
Okay.
Where you have hobbyist airplanes flying in and out.
We did it all by ourselves. We went out without a hitch.
Nice.
We went out to eat burgers at Monderosa's. It's a restaurant between Nenana and the Clear Airport. So it was a very good experience. It was a bonding exercise afterwards. But since we realized we weren't going to be seeing any snow for maybe the rest of our lives, we had like a huge snowball fight after we launched both of our balloons.
Oh my gosh.
But yeah, that day was definitely the highlight of my experience.
Just move to New England or anywhere in the northern U.S. You'll get snow.
But yeah, that's mine.
Very nice.
Michelle, what was the highlight of your experience?
The highlight for me is that I sent a camera into the atmosphere. I mean, it was just so cool. The fact that I had to keep it warm enough for it to keep taking pictures, because at a certain temperature it's going to stop working. So that was definitely a highlight. And then another thing is I can say that I've done stuff that no one else has. I've walked through a frozen river, I went dog sledding, I seen the Aurora Borealis. So, and a lot of people don't even know what that is. They're like, what is that? I'm like, the northern lights, the sky turns green, maybe, yeah. So
Big fault.
that's definitely my highlight is just going through that experience and having data that was out of my hands and into the atmosphere.
That's excellent.
I got to do hiking, which was awesome. And it's the first time being on a real hike, and I got to do it in snow in Alaska, and I saw what I thought might be bear tracks, and I love that. Getting out to be in the wilderness was something I hadn't gotten to do a lot since I started college because I gave my entire life to school. Being out somewhere where you can stand outside and you can't hear anything.
Mm-hmm.
It was a very cool experience for me. So I love being out in the wilderness and getting that chance to see one of the last untamed places on Earth.
That's excellent. Yeah, that's one of my favorite things about just doing research experiences as a student and now is just the opportunities to get to see something completely new, completely different. I was telling somebody a story this past weekend about how the first time I actually saw the Milky Way was in college. I was on a trip out in Arizona. It was part of a summer internship, and it's like the first time I ever saw the Milky Way because I grew up in a city. You don't see those things.
Exactly.
And so yeah. Or you guys, you get to see snow because you live in Texas where there's not a lot of that. Yeah, I know. I get ridiculous pictures from my little brother of the weather down there in the winter. I hate you all. So yeah, that's really great that you guys got that experience. So yeah, and I love that you guys are sharing it. So we're definitely going to make sure that the blog link gets posted in the show notes for you guys watching, for you guys listening. Please do check out their blog. Like I said, I'll post the link in the show notes because I've already misplaced it. There it is, usip-uh.blogspot.com, and I'll post that for you guys. And I hope you guys keep sharing your experience as well. Because that is really, really awesome. So thank you guys for coming. Do you have any last final thoughts you want to leave us with?
I would say that if you have any follow-up questions or you want to find out more, or if you have students that you want to get involved and you want us to talk to them, you can always hit us up at usip.uh@gmail.com. You'll see that same email on our website and everything. I'll personally be answering that. All of the members in our team have login to it, so that's kind of like our main point of contact. If you see anybody here or you want to know about any of the other experiments that we're talking about, always feel free to contact us at that specific Gmail account, which we have a Google Plus page for too. You can hit us up anywhere at that. We, like you said about us sharing, we love sharing. If this talk was 4 hours long, we would be able to fill it with 4 hours of talk. I appreciate, my grades appreciate that it's not a 4-hour long talk, but
Yes.
yeah, we love sharing, so don't feel hesitant at all to reach out to us about anything you might want to know or learn more about.
That's awesome. Well, thank you guys so much. Thank you everyone for watching. Sorry, Georgia, I'm still getting feedback from you. So if you want to say bye. Thanks everybody for watching Learning Space. We will be back. Where's my calendar? I don't know. My calendar's over here on the wall. I'm looking off at the wall at my calendar. I have a space calendar and I have a dog calendar because I also love dogs. But our next show, I think, will be The Colors of Nature is the topic. This is a, I'm going to double check. This is a STEAM project, so it's, oh, no, yeah, so our next, okay, let's go over this again. Our next broadcast, so Pamela Gay will be doing Inspiring Science Education on next Wednesday on the 22nd, back to our normal time, which is 1 o'clock Central. The 29th is the 5th week of the month, so we don't, 5th Wednesday of the month, so we don't have something planned, but I am planning to do a short video quickie, so there'll be a short recorded video for you guys. And then the next one we have is May 6th will be our next live episode for Learning Space. We'll be talking about the Sloan Digital Sky Survey and their Voyage program, which is a way that you can use Sloan data for activities and educational projects with your students. So we'll have Karen Masters and Kate Meredith to talk about that. And that'll be our next live show on May 6th. Weekly Space Hangout with Fraser Kane is on Friday at what time? Noon Pacific, and the Astronomy Cast will be noon Pacific on Monday. So thank you guys for watching, and we will see you soon. Bye.